Okay, so this is part two of the lesson on solving rational equations. And remember in part one, when we solved rational equations, our denominators were monomial factors. Okay, so if you go through all the examples we did, the denominators were monomial factors. Um, they were monomials. So see all monomials. All right, so go back and make sure you review part one. And so when we did part one, sometimes we ended up with so we multiply both sides by the LCD. Sometimes we ended up with a linear equation. And then sometimes we ended up with a quadratic equation. All right, so in each case, it's very important that you go back and look at those. But in part one, we did deal with just monomial factors. In part two, we're going to look at rational equations that are not monomial factors, in which all of them are not monomial factors. But this is the easier kind as well, because the factors or the polynomials that are in the denominator um, will have a GCF of 1. Okay, so what that means is this. So for example, number 1, suppose I had 6y divided by y plus 2 minus 3 equal 2y divided by y plus 2. So part 2, if you look at this denominator is y plus 2, this denominator is a 1, and this is y plus 2. Now, let me go ahead and make it a little bit bigger. So, so what I want you to notice is that, again, the first thing you have to do is to find the LCD. Now, before we go on, though, in part 3, you're going to see that these denominators you're going to have to factor. So let's go ahead and start talking about the steps to solving a rational equation. Step 1, factor the denominators of all rational expressions, and then identify any values of the variable for which the expression is undefined. Okay, so let's talk about that. So, step 1 is to factor all the denominators. Well, if you notice, y plus 2 is you can't factor that. It's prime. The GCF is 1. Okay, and those are linear factors. So, my LCD is y plus 2. That's your LCD. Now, the next thing you want to do is talk about your restrictions. So, let's find out what the restrictions are. So, the restrictions would be what makes each expression undefined. So if I look at y plus 2 here, so remember this expression, this rational expression is undefined when the denominator is 0. So ask yourself, where is y plus 2 equal to 0? Well, y plus 2 is equal to 0 when y equals negative 2. So that's one of your restrictions. Y, this should be y, cannot equal negative 2. Okay? Is this rational expression 3 over 1 ever equal to 0? No. I mean, ever undefined, excuse me. No, because my denominator is always 1. Is this rational expression ever undefined? Yes, it is. It's undefined when y is negative 2, but we already have it listed. Okay? So the only restriction is y cannot equal negative 2. All right, so let's now at some point we're going to come back and we're going to talk about well when is this needed? You're going to see in the next example. I think there's a situation where when we solve the equation, what we get is a restriction. So you're going to see what that means. Okay, so step 1 is to find the LCD and the restriction. Okay. Um, well, step 1 is to factor, excuse me, and then we identify the restriction, and then step 2 is to find the LCD. So we found the LCD, and so this is really step 1 and 2. Okay, step 3 is to, once you find the LCDs, to multiply both sides by the LCD. So remember in the last lesson, we put this side, because it has two terms, two fractions in parentheses. So go ahead and do the same thing. So 6y divided by y plus 2 minus 3 equal 2y divided by y plus 2. So now you're going to multiply both sides by y plus 2, just like this, y plus 2. All right, now, next step, remember, was to distribute. Don't reduce first. Remember, we saw that was mathematically incorrect, because not only is this being multiplied by y plus 2, but so is the 3. All right, now listen carefully to this. Write it just like I'm doing. So you're saying y plus 2 times 6y divided by y plus 2. Okay, see how that looks? Minus, now here's where you're going to have to do what I'm telling you. 3 times in parentheses, because this has been multiplied by y plus 2. Y plus 2, put parentheses. Because if you don't, you're going to say this is minus 3y plus 2, and it's not supposed to be. It's minus 3y minus 6. Okay, so put that in parentheses. Equal, I'm just going to rewrite this over. 2y divided by y plus 2 times y plus 2. Okay? All right, now, if you want to, and it may be a good idea for some of you, if you want to, you may want to go ahead and put, since that's a binomial, put that in parentheses. So that way you can see, all right, put that in parentheses, that in parentheses, that in parentheses. Okay? That may help some of you. All right? And I'm going to do the same thing in the next problem as well. Okay, now I'm going to go ahead and rewrite this. So actually, it's not going to be that messy. So I'm going to go ahead now and reduce. So when I reduce, I want you to notice what happened. Remember, the whole point of multiplying by the LCD is to clear these fractions. All right. So remember, what did you want that denominator to be? You want that denominator to be a 1, right? Okay. So y plus 2 divided by y plus 2 is 1. Y plus 2 divided by y plus 2 is 1. Y plus 2 divided by y plus 2 is 1. Y plus 2 divided by y plus 2 is 1. And so now look at what we get. We get 1 times 6y is 6y. Distributing the negative 3 here, I get negative 3y minus 6. Okay? Equal 2y times 1 is 2y. All right, so that's what I have. Okay, now let's go ahead and combine like terms. Now notice I went from a rational equation to a linear equation. Combine like terms. 6y minus 3y is 3y minus 6 equal 2y. And then I'm going to go ahead and add 6 to both sides. So I get, combining like terms, I get 3y equal 2y plus 6. And then subtract 2y. I want you to see what happens. I get 3y minus 2y is y equal 6. Okay, so y equals 6. So what I found, now first of all, we got to check to see, will this make any of my rational expressions undefined? So in other words, is that a restriction? No, because the only restriction was y cannot equal negative 2. So if I did all this correct, if I did not have any errors, then this is a solution. So you may want to check. So let's just check. Check y equals 6. All right, so if I go back, and wherever I see y, I substitute 6. So I get 6 times 6 over 6 plus 2 minus 3. And I want to see if that's going to equal, I'm right here, and I want to see if that's going to equal 2 times 6 divided by 6 plus 2. All right, well, 6 plus 6 is 36, right? 6 plus 2 is 8 minus 3. And I want to see if that's going to equal 2 times 6 is 12. 6 plus 2 is 8. All right, just use your calculator with that part now. So I want you to notice something. 36 divided by 8 minus 3 equal 1.5. And then 12 divided by 8 equals 1.5. All right, so that was correct. Okay, so that was number 1. Okay, number 2. So it wasn't that bad. Number 1 wasn't that difficult. Okay, number 2. So number 2, let's suppose we had 4 plus 18 divided by a minus 6 equal 3a divided by a minus 6. All right, so step 1, when solving a rational equation, step 1 is to factor the denominators, all right, and then identify any values of the variable for which the expression is undefined. So when I factor the denominators, notice that these denominators I can't factor any further Now let's ask ourselves, where's this? Well, first of all, let's look at this first one. Is 4 over 1 ever undefined? No, because my denominator is always 1. Is the second expression, 18 divided by a minus 6, is that ever undefined? Yes, because I have a variable here. Where's it undefined? Well, it's undefined when a is what number? What makes it 0? When a is 6. So what you need to do, if you didn't see that, is ask yourself, where is a minus 6 equal to 0? And just solve this equation. A equals 6. So that's where you get a restriction. So a cannot equal 6. And the same thing here. That's the same denominator as that one. So my restriction is that a cannot equal 6. And now the next one, we've got to find the LCD. Well, the only thing you see is 1, a minus 6, right? So what do you think the LCD is? A minus 6. So that's, remember, always think about this. If I want to make this a 1, then I better see it in my LCD. If I want to make this a 1, then I better see it in my LCD. Okay? All right, now once you find your LCD, then the next step is to multiply both sides by the LCD. So put this in parentheses because I have two fractions, two rational expressions. So 4 plus 18 divided by a minus 6 equal 3a divided by a minus 6. And then multiply by the LCD. Let's put that in parentheses, just like we did this one. See what I did to do that? Just like we did here. Put in parentheses. Since that's not a monomial, that's a binomial. Put that in parentheses. Just go ahead and do it. All right, now we're going to distribute this. So when you distribute this, I get 4 times a minus 6, see that? Plus 18 divided by a minus 6 times a minus 6. Okay, that's how that looks. This times this times this. Equals, and we're just going to rewrite this over, 3a divided by a minus 6 times a minus 6. Now at that point, just like we did this, okay, listen carefully, at that point we're going to solve this equation. So that's how you would reduce, okay? All right, so the whole point of multiplying by the LCD is to clear the fractions. You want this factor to be a 1 now, and now I can make that a 1. This divides into this, and then this divides into this. Those you get factors of 1s in their places. Okay, so now here's what we have. I'm going to go ahead and distribute this, so I get 4a minus 24 plus 18 times 1 is 18, right? Equal. And then over here, I get 3a times 1 is 3a. Okay? Now notice I went from a rational equation to a linear equation. All right, so now I have 4a minus 6 equal 3a. And then adding 6 to both sides, I get 4a. Combining like terms, I get 4a, that's 0, equal 3a plus 6. And then subtracting 3a, I get 4a minus 3a is a, that's 0 here, and then 6. Now, listen carefully to the new word. Okay. Notice that I multiplied both sides. I multiplied both sides of this equation by a variable expression. Okay? So when you multiply both sides of an equation by a variable expression, it is possible, you may introduce or get what's called extraneous, get extraneous solutions. And sometimes we just say they're false solutions. Okay, so hence the word extraneous now. Okay, in part 1, I didn't use that word because it really wasn't necessary at that point. Now it is. Okay, so listen carefully. So in part one, you found restrictions as well. So it just turned out that in part one, if you go back to part one, right here, our equations, the monomial factors, I'm sorry, the denominators were monomials. So the only restriction in every case was 0 because there was a monomial. If your monomial had a variable in it, the only way you can get a 0 there is if for the variable is 0. All right, but now we notice that it's not always going to be monomials in your denominator. Here I have a binomial, and the restriction was that what makes the rational expression undefined was when a is 6. Okay, so listen carefully. Notice that I solved this equation, right? And I got a to be 6. Well, if we go back and we check this, just like we did in the rest, what do you notice about this? Let's say this one right here. If a is 6, I get 14 divided by, and what's 6 minus 6? 0, right? Or that's 18. 18 divided by 0. What do you remember about 18 divided by 0? Well, that's undefined. So this cannot be a solution to this, because this, a equals 6, makes this undefined. And remember, we cannot divide by 0, so that makes this undefined. Well, you may say, well, how do we get a equals 6? Well, here's the thing. Remember, I went from a rational equation to a linear equation. So this right here, a equals 6, is a solution to something. It's a solution to this linear equation. All right, even this one right here. So let's check. What's 4 times 6? 24. What's 24 minus 6? 18. What's 3 times 6? 18. 18 equals 18, right? But that's a linear equation. What was it that I wanted to solve? A rational equation. So what happened was, when we multiplied both sides by a variable expression, I ended up with a linear equation that had a solution, but that solution made the original undefined. So that introduced what's called an extraneous solution, a false solution, meaning that it's a solution to this equation, but it's not a solution to the original. So the point being this: whenever you have a rational equation and there are variables in the denominator, you find the restriction, you solve the equation, and you have to check to make sure, is this a restriction? If it is, then that means what you found was an extraneous solution. You found a solution to this equation, but it's not a solution to the original. Okay? So since a equals 6 was the only, sometimes we'll call this a possible solution. And so since a equals 6 is a restriction, then what you're going to say in the blank where it says solution, a equal blank, you're going to say no solution. That's what you say, no solution. Okay? Don't say extraneous solution. You say what? No solution. It has a solution or it doesn't have a solution. Okay? All right. So, again, now I need you to notice that a equals 6 was an extraneous solution. That's an extraneous solution, which means that it was a solution to this equation, but not the original. So what are you trying to solve? You're trying to solve the original. So what's the solution? You say no solution. That's what you say. No solution. All right. So hence a new word, extraneous solution. So sometimes when you multiply both sides by an expression that contains a variable, you may end up with extraneous solutions. These extraneous solutions are not the solution to the original problem. And you're trying to solve the original problem. Okay? So hence we just say no solution. Let's look at number 3. All right, in number 3, let's suppose you want to solve this equation. 5x plus 5 divided by x plus 2 plus 3x equal x squared divided by x plus 2. All right, so 5x plus 5 divided by x plus 2 plus 3x equal x squared divided by x plus 2. All right, so step 1, remember, is to factor the denominators. What do you notice about these denominators? They're already factored. You can't do anything with it, right? So then we find the restrictions. All right, so let's find the restrictions. What can't x be? Well, what makes this 0? What makes this denominator 0 when x is what? Negative 2. So if you didn't see it, you just say this, x plus 2 equals 0, and then solve for x. X equals negative 2. So my restriction is that x cannot be negative 2. All right, same thing here. What's the restriction? Was the same as this one, negative 2. Does this have a is this ever going to be undefined? No, because my denominator is a 1. 3x divided by 1. All right, next step is to find the LCD. LCD. All right, well, remember I want this to be a 1, right? So my LCD has to include this. I want this to be a 1. So my LCD has to include this factor. So the LCD is just x plus 2. That's your LCD. Okay, so now we're going to multiply both sides by the LCD. That's the next step. We're going to put this in parentheses. 5x plus 5 divided by x plus 2 plus 3x equal x squared divided by x plus 2. All right, and so that's where now we're going to say times x plus 2, put that in parentheses, times x plus 2, put that in parentheses. What do you think the next step is based on all the problems we've done at this point with parts 1 and part 2? Distribute. All right, so I'm going to get, let's write these first and then multiply by that. So this is going to be 5x plus 5 divided by x plus 2 times x plus 2 plus 3x times x plus 2. Okay, equal, I'm going to rewrite this over, x squared divided by x plus 2 times x plus 2. All right, now notice I multiplied every term by x plus 2. See it? All right. Now the next step, remember, is to solve this equation. So you're going to solve this equation by first reducing. So if you did this correctly, remember you want this to be a 1, and it now is because these divide out. Can't do anything here for right now except distribute. Over here, these divide out. So the next step was to reduce, and I did. Now let's go ahead and rewrite what we have. What is 5x plus 5 times 1? Well, that's just 5x plus 5, right? Okay, now over here, how do you think you get rid of these parentheses right here? Distribute, right? 3x times x is 3x squared. 3x times 2 is 6x. Equal, and that's just x squared, because x squared times 1 is x squared. All right, now notice in number 1, I went from a rational equation to what kind of equation? Linear. Here, I went from a rational equation to what kind of equation? Quadratic. All right, so let's combine like terms and put in descending order over here. So I get 3x squared plus 11x, 5x and 6x, 11x plus 5 equal x squared. Okay? All right, next step. Remember, this is quadratic, so remember, what do you want on this side? Remember, the ones we're doing is going to be factorable, so you're going to solve this quadratic equation by factoring. Well, you have to have 0 on this side, right? Because you want to use a 0 factor property. So let's go ahead and subtract x squared from both sides. And so I get 3x squared minus x squared is 2x squared plus 11x plus 5 equal 0. And now when I factor this, I'm going to get 2x, x, 5 and 1, and then plus and plus. And again, before you go on, always check. 2x times x is 2x squared. The outer is 10x, the inner is x, and you get 11x, and then 1 times 5 is 5. Equals 0. And now we're going to use a 0 factor property. Remember that? 0 factor property. And so when I set each one equal to 0, 2x plus 1 equals 0, so I'm going to 0 factor property. Notice that one of these factors, the product is 0, which means one of them must be 0. So either 2x plus 1 is 0 or x plus 5 is 0. And so notice I have a linear equation now, 2 linear equations. So 2x equals a negative 1, so x is a negative 1/2. Over here, I get x equal negative 5. Are any of these your restriction? What was the restriction? -2. Were any of these a restriction? Nope. None of them were restrictions. So notice number 5 says check the potential solutions. So remember we use the word possible solution. Sometimes I'll use the word potential solutions. Potential solutions. Those are my potential solutions. I gotta check them. But all you really have to do, guys, all you have to do is just check to see if it's a restriction. So is this a restriction? Nope. So if you think you did all this work correct, then those are your solutions. So my solutions are x equal -1/2 and x equal -5. Those are your solutions. Okay? Now, if you want to really check, though, you go back to the original, and where we see the variable, you're going to substitute these numbers. Okay? All right. Number 4. Let's do this one. X plus 6 divided by x minus 3 equal 2x divided by x minus 3. All right, step 1, factor the denominators. Can I factor anything? Nope, cannot factor anything. Then we're going to identify any values of the variable for which the expression is undefined. Where is this expression undefined? Well, that expression is undefined when the denominator is 0. So where is this denominator equal to 0? Where is x minus 3 equal to 0? Well, x minus 3 is equal to 0 when x is what number? 3. So I found my restriction. X cannot equal 3. Do the same thing here. Where's this fraction undefined, this rational expression undefined? Well, that's undefined when the denominator is 0, but that's the same as this one. So that's 3 as well. Now, I didn't do this one because that has a denominator of x over what? 1. So that's always 1. So since I don't have a variable, I don't have to worry about it. Because it's never going to be 0. It's always going to be a 1. Okay, so I found the restriction. Now the next thing I got to do is find the LCD. Remember, I want to get rid of this denominator. I need this to be a 1. So in order for it to be 1, I got to multiply this by this denominator, x minus 3. Same thing here. So the LCD is x minus 3. Once you find the LCD, then you're going to multiply both sides by the LCD. So let's put that in parentheses. X plus 6 divided by x minus 3 equal 2x divided by x minus 3. And then multiply by the LCD, x minus 3 in parentheses, just like this, times x minus 3, just like this. And then just follow the same steps as before. You distribute now. So you're going to say x times x minus 3 plus 6 divided by x minus 3 times x minus 3 equal, I'm just going to rewrite this over, 2x over x minus 3 times x minus 3. So remember, notice what you did. Every term, see all these 3 terms right here? These 3 fractions? Notice they're all being multiplied by x minus 3. See it? X minus 3, x minus 3, x minus 3. Do you remember what the next step is? Well, the next step is to reduce. So I can reduce this. I need that to be a 1. In order for it to be 1, I better see it here. So those divide out. And the same thing here. Those divide out. Now we're going to get rid of the parentheses here by using the distributive property. So notice this becomes x squared minus 3x. Now what is 6 times 1? 6. Equal, what is 2x times 1? 2x. All right? So notice I went from a rational equation to what kind of equation? Quadratic. All right, so I'm going to subtract 2x from both sides. And when I do that, I'm going to get x squared minus 5x plus 6 equals 0. And I'm going to factor. All right, so when I factor, I'm going to get 3 and 2 and both negative. So let's just check. X times x is x squared. The outer is a negative 2x. The inner is a negative 3x. When I add them up, I get a negative 5x. And a negative 3 times a negative 2 is a positive 6. And then I'm going to set each, remember now we're going to use the zero factor property. I have a product that's 0, so one of those factors must be 0. So x minus 3 equals 0, x minus 2 equals 0. And then notice I have 2 linear equations now. So that means x must be 3, x must be 2. Okay? Now remember, those are your potential solutions. Potential solutions. All right, so hence potential solutions. But we got to determine, are those solutions to the original? Well, that's where the restrictions come in. What's the only restriction you see? The restriction was that x cannot be 3. What do you notice? Right here, x is 3. So x is 3 is a solution to this. Y'all agree, right? Y'all agree that 3 is a solution to this? Because what's 3 squared? 9. What's 5 times 3? 15. What's 9 minus 15? A negative 6. What's negative 6 plus 6? 0. But the issue is that it's not a solution to the original because when I substitute 3 in, what happens here? That's a 0. 6 divided by 0 is undefined. So I can't use this. So this right here is what we call the extraneous solution. Now this one's fine because that's not a restriction. See this x equal 2? That's not a restriction. So the only solution is x equal 2. That's your solution. This is not a solution to the original. That's a solution to this, but it's not a solution to the original. So what we've done was we introduced, when we multiply both sides by the variable expression here, we multiply both sides by the variable expression, we introduced an extraneous solution. Okay. So the only solution is x equal 2. Now, if you want to check it, you can. Let's just check x equal 2. Because I could have made a mistake, right, along the way. So let's just check x equal 2. So we go back to the original, right here. So I'm going to rewrite the original. X plus 6 divided by x minus 3 equal 2x divided by x minus 3. And wherever we see the variable, I'm going to substitute 2. So I get 2 plus 6 divided by 2 minus 3. And I want to see if that's going to equal 2 times 2 divided by 2 minus 3, right? Okay, well, first of all, that's 2 plus 2 minus 3 is a negative 1. Y'all agree? And 6 divided by negative 1 is a negative 6. So 2 plus a negative 6 is a negative 4. 2 times 2 is 4 in the numerator. 2 minus 3 is a negative 1. And are those equal? Yep, those are equal. So x equal 2 is the only solution. All right, so that's going to take care of part 2. So in part 2, we did 4 problems. And notice that part 2 was different than part 1, because in part 1, we only looked at monomial factors. In part 2, our denominators are no longer monomials. All right, but this was the easy kind because the denominators you could not factor, and they were the same, right? So it was easy to find the LCD. All right, and then notice that sometimes we ended up with an extraneous root in this case, and since that was the only one and it was extraneous root, we would say no solution. Don't confuse this one where we said no solution with number 4. Don't say no solution here because there is a solution. This is not a solution, but what did work? That one. So that's a solution. Okay? All right, so that's going to take care of part 2.